Okay, in this video I'm going to cover section 2.2, more graphs and displays. In this case we are going to cover stem and leaf plot and dot plot. And then the qualitative data using pie chart, Pareto chart. I'm not going to cover this. Graph pair data setting using scatter plot, no. So from 2.2, that's all we're gonna cover, stem and leaf plots. So, like I said, we use histogram when we have large sample size. Large sample size is the size that is more than 30. How about less sample size? Less than 30. In that case, we are using stem and leaf plot. All right. What does that mean, stem and leaf plot? It reminds you like a tree, that every stem, there are several several leaves. And comparing to math, that's exactly the same way. Let's say if I take 30, and then 31, 32, 33, 34, 35, and all the way to 39. So 30 is going to be our stem, which means free, right? And from 1 to 9, it's going to be our leaves. So let's use that for the graphing and call it stem and leaf plot. So let's assume we have data 21, 25, 25, 26, 27, 28, and blah, 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 the rest of the data. How we're going to build stem and leaf plot in this case. So I'm going to put on this side, on the left side of vertical line stem, 2, 3, and 4. And horizontally on the other side of the vertical line, I am placing the leaves 1, 5, 5, which is here, 1, 5, 5, and then 26, look, 6, 7, 8. For the stem of 30, we have 0, 6, 6. Here it is, 0, 6, 6. And 45, we have 4 is a stem and 5 is the leaf. Now, what if, let's say, we have next is, for example, 67, practically skipping 50, right? In case like that, what we're gonna do, we write here 5, okay, and we don't put here anything. So that means there is no leaf, and because the stem without leaf, that means it's missing. Leaf is missing, so the number 50 something does not exist. But instead we put 67. Now you would ask, what's wrong with putting 0 here, meaning 0 leaf? If you put 0, that will means we have the number 50, which we don't. Okay? Which we don't. Therefore, we cannot put any number here. All right? And vice versa. If we want to read the number based on given chart, it's going to be 21, 25, 25, 26, 27, 28, and so on. Now, what's the advantage? How do we read? How do we analyze the stem and leaf plot? Very easy. Let me clean this. Okay, so what I'm going to do, provide this line like this. What do you see? Can you see the graph is skewed? Yes, it's skewed towards right? So that means data are not evenly distributed here, right? So what do we do with not evenly distributed data? Let's again compare to life. If we have a tree growing in our the backyard, and one stem is growing way out of way, so what do? We take scissor or something and cut it, correct? The same way, that's when we said we organize the data, that's what we do. Unnecessary data we cut off because we don't include in the sample, we don't need it, which it would be this way. And approximately this is gonna be symmetric and evenly distributed data. Okay, so in this case, stem and leaf plot, we have possible outlier. Well, if I add 6 and 7, but if I stay with 45, so maybe I could even cut, depends on how much I have to have it precisely symmetric. Then I would cut this and would be ideal symmetric and evenly distributed database. That's how we cut these, arrange the database, sort it out. Let's say if I take histogram also, for example, I have such an histogram. Okay. Look here. It's, if I draw the line, it looks like it's skewed to the right, right? I have here too much of data that I don't need it because it's not centralized. It doesn't locate it where all data centralized. So I take and cut it. Let's say from here, I will cut it off, have it centralized, and organizing. That's what I do, sorting out this one. This piece I will throw out and use only the data that are ordered and centralized. Just like in life, let's say if we are talking about society, we are talking about working, healthy society. The ones that are in prison, those are outliers of the society. Just like here we have outliers. We don't consider them as a part of healthy society. Well, obviously, I'm not counting the ones that are there by mistake, obviously, or we know sometimes not guilty people are going to jail because they can't prove their innocence. So, therefore, it's kind of a rough comparison, but something to give you idea. Or the tree is a good idea when it's growing out of way, it's outlier, we just cut it. The same way is in the case of this database. So this is method of stem and leaf. So what is advantage of stem and leaf comparing to histogram? The advantage is that you can see here every single element where it's located. I can see 21, 25, if it's specifically in centralized data, or it's close to the end, or where it is. While in the case of histogram, you can't locate every single element because it's broken into groups, and every single column shows group, and then where within group is located, that's on histogram, you cannot see it. Okay, so well, we are going to construct a stem and leaf plot. Here is the example. I like this example. It's typical business example. The following are the numbers of text messages sent last week by the cell phone users on one floor of the college dormitory. Display the data in a stem and leaf plot. So, first of all, we have here bunch of text messages, and look how many text messages they sent within 1 week. 155, 159. That's crazy. It's only young people can text message this much. So if we build stem and leaf, that's what we are going to get. The lowest number is 78, and the highest number of text messages is 159 messages in 1 week. So Let's build it. Here it is, 78, and there's nothing at 80. There is nobody who would text 80 something messages or 90 something, and it's coming to 105 and all the way to 159. Here is in the arranged order. Excuse me, in the arranged order. So let's work with arranged order, and if I provide this line here, we can see that these numbers are not evenly distributed, right? So this is kind of outlier which we can cut off, and we will have approximately, I would even cut this piece, so we would have approximately like this piece, we would have evenly distributed database. Now, so how the businesses are taking advantage of statistics, they can use to their benefit. We all know that so I don't know if they have it now, but before they would advertise that pay $5 only and you can text message unlimited. The truth is, it's not that's a privilege. You pay $5 and unlimited text. They do experiment like this, statistical analysis. So the youngest people are texting the most, right? And here we are, students are texting the most, and they find how much maximum they are texting. How 159 text messages. So they calculate how much it will cost 159 text messages, and they come up with $5. And then they advertise, pay $5 and you can text message unlimited. But the bottom line is you are paying $5 and you never use that much text messages. Adult people usually don't text message this much, because 159 text messages, that means you are eating, breathing, sleeping with these text messages, correct? So you practically paying more than you use it, right? So that's how these businesses, let's say phone providers, take advantage. That's why their profit is going exponentially, not linearly. Now, another case where they take advantage also of such type of statistical analysis, let's say a couple of years ago, I don't know if you remember, they had a plan up to between 500 and 800, the 100 minutes, and then between 800 and 1000 minutes, and then 1000 and above. Then every time if you would go beyond of your plan, you would pay a much more expensive dollar amount, correct? Yes. So mine was up to 500, but then when I started teaching again, students were calling me so not to go beyond of my limit. So I decided to change the plan, take between 800 minutes to 1000 minutes, which would be plenty for me. And fair enough, I looked at every single provider and I could not find that plan, 800 to 1000 minutes. So the first plan was between 500, 800, and then after that, above 1000 minutes. What does that mean? They provided analysis like this. They looked where data are centralized, and it turned out it was 500, 800, and 1000 minutes. And they took off this plan out of suggestion. Why? Because their profit wouldn't be as much as when either you go beyond of 500 minutes or you order you get 1,000 to 1,200 minutes more than you use. So one way or another, they are getting deeply in your pocket, and you pay more than you use. This is how business benefiting from statistics. Do we understand that? Okay. Next, the other version of stem and leaf, there's another data set graphing, is a dot plot. What is dot plot is interesting. So when you get your database, if you have identical data, you just put one above another and you build kind of this type of vertical column. See here and here. Where is it good to use this, and why do we have stem and leaf and dot plot all of a sudden? Dot plot is very convenient to use, for example, in automobile industry. Well, we all know that if car is, let's say, 8-cylinder, it's using about 21 miles per gallon. The mid-size is using 25, 26 miles per gallon. Compact, they use 27, 28, and then coming hybrid, and then electrical. So let's assume they are reporting to Consumer Report, Honda reporting, Toyota reporting, I don't know, Volkswagen reporting, and Hyundai reporting anyway. And as they report the same, similar or same mileage per gallon, they lined up in the vertical column, just like here, for example. And the one that builds more column, vertical column, that is taken, let's say, as a approximate calculation that, let's say, the mid-size cars are using 25 miles per hour per gallon. The compact one are using 30 miles per gallon or 28 miles per gallon. 36 is a hybrid. 45 looks like is electrical car. Okay, it's convenient for this type of business to get Consumer Report, and that's how we know that how many miles approximately it's gonna take your car, use your car, based on the size of engine of your car, based on how many cylinder your car has. All right, that's a dot plot. Now the same case with students dormitory text messaging, we are going to build on dot plot sort of the graph. Let's see what's going to happen here. Here it is in the format of dot plot. We are going to get the highest, the most people are texting 125 the messages per week, and what is going to be our centralized part? It's going to be right this, right? Or rather saying, let me go like that. Well, okay, I'll just fix it. Right? So, and the rest, this one are outliers. So when we are exploring centralized data, what we will do, we cut off these outliers and then explore the data are centralized. This is another tool that help to descriptive statistics to collect data and then organize the data and then analyze the data. And then inferential statistics will take the result and try to make sense out of it. All right? So 2.3, I guess I'll record in a minute. 2.3, like I said, I better post the separate section so it would be easy for you to find and watch it every single section. All right.